This is Dr. Kavita Singh, Associate Professor, Institute of Aeronautical Engineering. Today we are going to discuss a topic called as height measurements by relief displacement. So, how can we determine the height of an object? Height of an object means through an aerial photograph. When you take an aerial photograph, with the aerial photograph, vertical photograph or oblique photograph, with the help of these photographs, how can we are able to measure the height of the building or height of the object? Object in sense, if you want to measure the height of a tree also, we are able to measure. If you want to measure the height of a building also, we are able to measure. So this we are going to understand, we are going to learn about this topic. How can we use the aerial photograph and we are able to measure the height of a building or any kind of object. So let us enter to this topic. So in this topic, first of all, we have to understand what is a relief. What do we understand by relief? So generally, in general terms, relief means it's a up and down of the topography, either hills, either plateau, either plain. So any type of area, wherever you see. So relief is the difference in height between 2 points. Difference in height between 2 points. That means 2 points in sense if there is a plateau, if there is a mountain, if there is a hill, if there is a plain. So what is the difference between the height? So always in a topography there is up and downs everywhere. So this all kind of topographical features are called as relief. Now with the help of this relief, if the relief is little displaced means if it is moved from its position, exactly not showing in the photograph properly, then we are able to measure the height of the object with the help of this relief displacement objects. So which is the relief is the high point and the low point on the landscape. So this is measured in feet or in meters. So relief means like if you are going to measure a height of an object, if you are going to measure the height of a buildings, so this we can measure in the feet or meters. So this will be in meters, not in kilometers. Generally we measure a building in meters. So because kilometers will be too far, we cannot measure the building in kilometers. So always the building or an object is measured in the meters. These are the units how we can measure the height of the object. Now relief structures can also be defined as a qualitative characteristics like low relief plains or high relief hills. So we can just define it as a qualitatively, like if it is a low relief or it is a high relief. Now if you see in this next slide, these are the different kinds of relief. Here we have sea, we have plain here, we have a plateau here, we have a mountain here, right? This is one mountain, this is one mountain. So there is a difference between this mountain and this mountain, right? Both are mountains, both are a relief structure, but there is a difference in height of this mountain and there is a difference in this mountain height. Here you can see a plateau here. So plateau will be always low to the mountains. So this is low area, this is high area. Now again, if you go to the plain, this will be more lower to this. So you have a low, medium and high. And again, if you go more lower to this, you have a sea, right? So these are different relief features. You have a sea, plain, plateau, mountain. So we have a different relief features on the earth's surface. So high point and low point. You have a high point here, you have a low point here. These are the two different points if you differentiate in a relief feature. With the help of this, like if you want to take a photo of this area, suppose your camera is here and we are going to take a photo of this area. So camera will be capturing this all information, but only thing is here you can see the top of the sea, plain also top of the sea, plateau also top of the plateau. But in case of mountain, because it has a height, you may see the top and side both. So this is called as relief displacement. Now these are different kinds of relief. Now what is relief displacement? So we understood, right? What is relief? Relief is up and downs of a topographical area, either hills, plateau, plains or any kind of topography. Now we have to understand what is a relief displacement. So first let us understand the definition of relief displacement. So relief displacement is the apparent horizontal shift of features in an aerial photograph caused by the angle of the camera lens. So it occurs when the terrain has elevation differences and these displacements need to be considered when making accurate measurements or maps. Now, if you have a relief displacement, how can you do the correction of this? So, if you want to do the correction of this relief displacement, to measure the true horizontal distances on a relief displaced photograph, corrections must be applied. These corrections involve adjusting the apparent positions of features to their true positions on the ground. Various methods and software tools are available for relief displacement correction. So different softwares we can use it for the correction of the relief displacement. So now let us understand with this photograph what is exactly the relief is. So we have a two different photo here, photo number A and photo number B. Okay, both are the same area photos. So you can see buildings here, building 1, 2, 3. Now here you can see the same buildings 1, 2, 3. Right? So here you can see what is the difference in these two things is. Here you can see top of the building. This is the top of the building. Top of the building. Now in this picture, what you can see here, top of the building is there. Top of the building is there. Top of the building is there. And the side of the building is also available. So this area is also visible in this. This area is also visible in this. But in this you can't see in this portion, this area is not there. So this kind of view is called as relief displacement. I'll let you know with a very simple example. For example, you have a vertical photo. So in a vertical photo, you can see the top of the object. Top of the object. Okay. Same photo, same building. Suppose this is a building. This is a building. Same building, when the plane moves in a direction, when it keeps on moving in a direction and when it clicks a photo, so same building in another photo, how it will look like? Suppose this is the photo. So this building, suppose it appears here. So it will be like here, like this. Somewhat like that, it will be visible. So here in this building, what you can see the top and you can see the side. Okay, side. So this much portion is displaced. So the image looks like this, somewhat slant. So this is called as relief displacement. Here in this photo also it is visible. You have a top view. Here you can see somewhat the building is looking very slant. So wherever you see the high towers or the buildings which are having more heights, the relief features which are having more heights, so they are having more relief displacements. Now in this picture, as I told you just now, if you see true roof areas, blue polygons, same thing I showed you in the previous picture. So here you can see the roof here, blue color one. So blue color one is having the true roof areas and building coverage areas, red polygon. So these are all building coverage areas. Now and detected hidden areas, where these are all green polygons. So these are all detected areas called as relief displacement. Right? Next, we have a photo, one more photo here. So this is a aerial photograph and it is having a very high resolution. High resolution in the sense it may be with a resolution of 1:500, 1:1000. Why? Because you can see most of the features in this image. It's very clearly. We can interpret this images very clearly. Like this is a road we can see. Direction of the road. Some vehicles are going on. And you can see the building here very clearly. You can see a building here very clearly. Trees you can see very clearly. And there is one more building here. So just now in the previous picture what you have seen, when a photo is taken, so slant view of the picture. Like in this building you can see top view and side view also we can see. Whereas in this building you can see only the top view. But this is the photo of a same photograph. So what is happening is maybe the camera is somewhere here, somewhat here, and it is captured like this. So this images you can see, this is vertical, this is also vertical, this is also vertical, these all are vertical. But here, because the building height is more, that's why we can see the building side. So this displacement we call it as, maybe in the other picture, this is one picture where as the flight goes on in a direction. So this is one picture clicked here. When it goes on to the next picture, if we click here, maybe in that photo, this building only top view we can see, because the flight is keep on moving. So in that building top view we can see, and the third photo you can see this side of the building. So this kind of displacement we call it as relief displacement. Now here you can see there is a principal point here. I hope you remember what is principal point. In the previous lecture we have already discussed, and this is the line of flight. This is the flight line. It is going like this. This is the principal point. If this is the principal point, that means if this is the principal point, that means this photo, this is the aerial photo, only the 1/4 portion is displayed. So this is the 1/4 portion from here to here. So this is displayed, right? Rest. So if this is the principal point, if this is the principal point, that means only this picture is displayed. So rest all is not displayed. So out of this 1, 2, 3. So third one is displayed here. Rest 3 is not displayed. So why? Because the principal point is given here. Next, if you see how to calculate the object height. Now we already came to know what is relief displacement, how we can just get to know that the height of a building, if we see the side of the building and if we see the top of the building, we are able to calculate the height of the object or height of any kind of building. So to calculate the object height, we have a formula, that is h is equal to dh by r. Now here d, r, h, h. So what is d here? Relief displacement on the photograph. That will be if this is your building and if this is the displacement from here to here. So relief displacement, this top and base. So between top and base, how much measurement it is there, that is called as d. Now r is the radial distance from the principal point. H is the height above the datum of the object point, and capital H is the flying height above the same datum chosen to a reference H. Now in this photo, let us see D. So as I was telling you, what is D? D is this distance, top to base. Top to base. So if you see here, top to base means this is the top, this is the top, and this is the base. Okay. So from here to here, what is the distance? So from here to here, if we measure, so that is called as D. So this is the displacement we have to calculate. Now R is the radial distance from the principal point. So what is the R here? So as I told in the previous one, if this is the principal point in this photo, here is the principal point. So you have to just draw a line from principal point to this object. So that will be the radial distance from the principal point. Now H, this you have to find. Okay, height above the datum of the object. This we have to find out, and we will be knowing the flying height of the aeroplane. So in the next slide, if we see here with an example, I'll let you know. So calculating object heights can be determined as follows. Calculate flight altitude by multiplying the RF denominator by the focal length of the camera. Now here is the formula, D into H by R, where H is the object height, this we have to find out, and D is the length of the object from base to top. Length of the object from base to top. Now R is the distance from principal point, radial distance from the principal point. Now this is in a simple way, if you want to understand. Suppose this is your exposure station, and this is the object. this is the height we have to measure. So this is the base and this is the top base. So this we are going to measure. This is the object. So how much distance is from the top to the base? If we get to know, then we are able to calculate the height of the object. Now here, what is D here? D means length of object from the base to top. Length of object from base to top is how much length from here to here. Okay, that is called as D. Now, in a simple way, if you want to understand, this is one more example given here. You can see this aerial photograph. This is an aerial photograph again. Aerial photograph. Now in this photograph, again you can see here you have a principal point. Principal point. So this is again 1/4 of the image because the principal point is somewhere here. So 1/4 of the image means this is the image. This is the photo. Now here principal point means this portion of the photo is visible here. Photo number 4, let us see, or photo number 3. So this is visible here. Now here is the principal point. Now we have to measure this tank. We can see 2 towers here. So let us consider it is a tank or a tower. Now the distance from top to base. So here is your top, here is your top, or here is a base. Okay. So what we have to do if you want to calculate the height, what you have to do is you have to just take the aerial photo and you have to take a scale and just you have to measure the height in the aerial photo in centimeters or mm. Or else in the software we can do, suppose this is the software called as ADAS. There you can just add the digital image and with the help of the tool we can just measure the height of from here to here, from base to top, and then whatever we get in mm, suppose 2 mm, 3 mm, 4 mm, 5 mm, based on that, if we get to know this displacement, then we can calculate the height of the object. So first thing what we have to know is top and base we have to calculate. We have to just find out with a scale or with a tool. When we are using the software, with the help of the software, we can find this distance. And if you are using a hard copy of the aerial photo, then we can use a scale for just finding this top and base. And later what we have to do, you have to just measure the distance from PP to the object. Which object? Which object we are going to measure. So PP to the object, how much is the distance, and top to base, how much is the distance. So what we should find out is D, what is the distance, and principal point to the this object, what is the radial distance and the object. So if you get to know that, for example, photo relief displacement of tank D, that is 2 mm. Okay. So this is what I was saying. 2 mm means, suppose here this one. So 2 mm we have this as, so this is top and this is base. So this we have 2 mm. Okay. Now we have radial distance from the principal point to the top of the tank is radial distance from the principal point, it is 71.5 mm. Okay. Now we have just measured this radial distance. We have just measured this top and the base of the object. Now we are having the value of D, that is 2 mm, and we are having the value of the radial distance from principal point to the tank. So from here to here we have the value, from here to here we have the value. So now we know the flying height of the plane. So the flying height of the plane is 918 meters. So we know the flying height of the plane and we have just measured the radial displacement, relief displacement, that is 2 mm, and radial distance from principal point to tank, that is 71.5 mm. Now what we have to do, just we have to put on the formula, that is H is equal to D into H by R. Now h means this we have to find. H is the height of the object. This is the height of the object which you have to find out, right? Now d, we have this. We have just measured d is 2 mm, and h we already know, that's it, 918 meters, and 2 mm into 918 meters by 71.5 mm. So this will cancel and our answer will be meters. So we'll get the answer in meters, that is 25.7 meters. So approximately, if you round off, you will get 26 meters. So actual height of the object is 26 meters. So this is one example how we can measure with the help of the relief displacement. So it's a single photo method. So if you have a aerial photo with a relief displacement photo, in vertical photo we can't measure. This photo is with a single photo. So if you find any object is displaced, then only we are able to measure the height of the objects. So the example, I hope you understood how we can. Now in cartography, relief refers to the depiction of elevation and terrain features on a map. So cartography is related to the maps. So when you talk about cartography, that is related to the maps, like all types of world maps or any kind of mind maps we prepare, or these all kind of maps we get to know in the cartography features, or relief areas, mountains, rivers. This kind of features you will get to know in this cartography. So relief refers to the depiction of elevation, terrain features on a map. Relief displacement occurs when three-dimensional features such as hills and valleys are represented on two-dimensional map. So in cartography it is said that relief refers to the depiction of elevation and terrain features on a map. Relief displacement occurs when three-dimensional features such as hills, valleys are represented on two-dimensional map. So due to nature of mapping or curved and irregular surface onto a flat plane, some distortion is inevitable. So next, relief displacement can cause features to appear shifted or distorted in their horizontal, vertical positions on a map. So cartographers use various techniques such as contour lines and shaded relief to minimize the impact of relief displacement and provide a more accurate representation of the terrain. So this work is done by the cartographers who usually prepare maps of all types of relief. Relief means all type of mountains, region, plain area, hilly areas, or some kind of objects up and downs. So these all they prepare, the cartographers are working on that. So here one more example. Like we have a datum plane here. So I hope you remember this nadir point. So this is your exposure station. And this is your nadir point. Nadir point is what? The point exactly beneath the exposure station. Okay, so this is your nadir point, this is your datum plane, this is your exposure station, and this is the object where you have to measure the height of the object. So A and B is given here. A, B. A, B means A is the top, B is the base of the object. So in simple terms, this is how we can just understand, and this will be flying height. H is always flying height of the plane. Flying height of the plane means from the datum, from the mean sea level, how much is the distance when the plane is flying, of a distance, like it can be, it will be always in meter, like 900 meters, 800 meters, 700 meters, 500 meters, depending on the scale of the aerial photograph. How much is the scale of the aerial photograph? Based on that only we are able to decide the flying height of the flight. Okay. Now in the other slide, this is more clear picture you can see here. Very clear picture. So this is your relief displacement again. Now you can see the top, the side. So if you want to find out the height of this building, now what we have to follow? We have to follow, first thing what we have to do, we have to find the D. So what is D here? D is top and base. Top and base of the object. So what is the top and the base of the object means? What we have to do is, you have to measure the distance from top to the base. Now here in this picture also you can see the displacement. So relief displacement is due to differences in relative elevations of objects. The taller the object, the greater the relief displacement. If the object is taller, the relief displacement will be more. Now in this picture you can see more distortion. Why? Because if you remember, we have discussed about the different types of photographs, that is vertical photograph and oblique photograph. So always the relief displacement we will find in the oblique photograph, not in the vertical photograph. Vertical photograph is always visible, there will be no distortion. Why? Because here is the aircraft, weather point, principal point, isocenter. So this is same. So these three things will be exactly at this point in the vertical photograph. Whereas in the oblique photograph, if the aircraft is here, so another point always it is beneath the surface, right, of the aeroplane. Isocenter, it falls, the line falls between the nadir and the principal point. So what is principal point here? Principal point is here. Principal point is here. If the principal point is here, so your photo will be like this. If your principal point is here, that means your photo is, the captured information is somewhere here. Okay, if principal point is here, your photo is like this. So this much area is, it is captured. So another point is here. Okay, isocenter is here, principal point is here. That means it's a oblique photo. Now you can see the no distortion in this vertical, and you can see here the distortion. Why? Because it is taken from an angle. Always the photo which is taken from an angle. Now this photo, if you see, this is taken from an angle. So that's why we are able to see the displacement. Otherwise, if you take a photo exactly vertical to the ground, there will be no distortion. There is no distortion here. The lines are very simple. Whereas in this photo, you can see the lines are distorted. Here you can see the big grids. Here you can see the smaller grids. So because it is taken from an angle, that's why the distortion will be more in this kind of images. So relief displacement, height measurement of an object, we can do with the help of the low oblique photograph. Not even high oblique photograph. High oblique photograph is with an angle of 60 degrees where the horizon is visible. So that will be not suitable for this. So always if you want to measure the height of the object, we have to take a low oblique photograph. So here very clearly we can understand. Now here you see again one more photo we have here. So in this photo also relief displacement is very much clear. So you can see not only this building, these are all tall buildings. You can see here, these are all tall buildings. So wherever you see the short buildings, you can see only the top of the building. Now if you see, the more the taller the building is, more the displacement we can see. Now here you can see this building is not too tall, it's a little short. So displacement is also less. Whereas this building is too much tall. So here displacement, the top is more and total side is visible. So this much displacement it has occurred. Now here also you see in this building, here from here to here. So this much displacement it has occurred. So shorter the object, displacement is less. More higher the object, displacement is more. Now you can see this more tall buildings here, this much height. So more tall buildings, more displacement. So with this displacement, if you are able to measure the height, because measuring the height of a taller object is very hard. Physically, if you want to go there and you want to measure it, we are unable to do. So that's why we take a help of the aerial photograph to measure the height of the object. So if this building, if you want to measure, just take a low oblique photo. So this is low oblique photograph only, because we can see there is no horizon in this, but we can see the side of the object here. Low oblique photo. So in this, what we have to do now? Measure this building top and base. So this will be top and base. This will be our D. Okay. So if we get to know top and base, now we have to find out the center of the image. So center of the image is what? Principal point. So this is one portion of the image. So principal point, suppose it will be somewhere here. So from principal point, you have to measure the base of the object. So this you have to find out, this you have to find out. If you find this D and R, then we are able to measure the height of the building. Okay. Next, suppose we have measured displacement of a tree. So if you want to measure the displacement of a tree on a flat ground, so or D is equal to 2.5 mm. So there is a flat ground where you can want to measure this height of a tree. Tree in sense this is the tree, suppose. So if you want to know the height of this tree, so what we have to do is, in an image, if the tree is visible like this, then again you have to take the top base. So this measurement, what we can do is, if you are using a hard copy, we can just use a scale to measure. So it will be always in mm, because we are measuring in the photo, so that we have to convert it later into meters, because in the image always we cannot measure in meters. So we have to just assign a scale to it. So suppose it is 2 mm or 3 mm, 4 mm. Later what we have to think is, if 2.1 mm on, how we have to consider is, if 2.1 mm on the photo, so this 2.1 mm can be 80 meters of height. Actually, real if you want to see the real image, so in that the actual height will be in meters, not in mm. But what we have to do, because we are taking a photograph, we have to assign it in mm, then later we have to convert it in meter. So the distance from the top to the of the tree to the nadir of the photograph is 79.4 mm or 79.4 mm, or R is equal to 79.4. Okay, then we have to find the D, and we have to find the radial distance from PP, principal point, and then just we have to put on the formula to get the actual height of the tree. Now, relief displacement is a shift in an object image position caused by its elevation above a particular datum. A vertical object such as building or a tree will appear to be a line along or line radial to the imaginary point. This deformation is called as relief displacement. Okay. These are different definitions again. So relief displacement is a shift in an object image position caused by its elevation above a particular datum, a vertical object which will appear and be lying along a line radial to the image or nadir point. So this deformation we call it as relief displacement. So these are different examples of relief displacement again. So this is the tree which we are going to measure. So this is the focal length of the camera. Now we are going to find the height of this. So what we have to do again, same, top and base we have to find. Okay. Now these are different way of displaying again. So these are two different things. Now layout of vertically extended object within an image. So if you remember, vertically extended means, so this first image, it is the same picture. Actually, 1, 2, 3. So these are all 3, but same picture, same image we have. But only the difference here what you have is, this is a vertical image. So if it is a vertical image, you can see the top of the object, only the top of the object. So you can see all these buildings are visible, only the top of the object. Now if you go to the second one, here what you can see here is side view is visible, side view, side view, side view. So if the camera is somewhat on the top, so here is the nadir, so nadir and PP. So what? So here, if the camera is somewhat here, so when it captures the image, so this building has appeared vertical, but rest of the building has appeared side view. We can see side view. We can see side here or side view. So this image can be used for the measurement of the height. So relief displacement, as found in the frame imagery, entire image capture at the same instant. Relief displacement is always radial with respect to the negative. Now this is one more photo number 3. So relief displacement as found in push broom imagery. Push broom imagery, this is one kind of image which is we get it from the push broom. Push broom is a sensor from where we get this imagery. So the image is built up over the time by the platform motion. Relief displacement only exists with a line. So it's still it is a still radial with respect to the nadir point, but there is a different nadir point for every line. So therefore, the only component of relief displacement is cross track. So it is always cross track. So there is no along track components. So platform motion is up and down. Now in this image also you can see if somewhere the camera is here. Okay, so when it captures, it will capture these 3 buildings. On the top view is visible, whereas rest 2 buildings you can see side is visible, side is visible, side is visible. So this is from the push broom imagery of a aerial photo. Now there is one more example here. Same example till now what we are discussing. So in a different way, I'm trying to make you understand. So here h is equal to dh by r. H is the object height. This we have to find out. D is the distance of relief displacement, and flying height of the above the ground. So radial distance from the principal point to the end point of the object. For example, this one. This is the principal point, and this is the object which we have to measure. So top to base, what you have is 2.01 mm, and radial distance what you have is 56.43 mm. Now 2.1, 2.01 mm into flying height, that is capital H. Flying height you have is 12,220 meters by 56.43 mm. Now this you get in meters again, that is 43.45 meters. Flying height is 1,220 meters. So if you have a flying height of the image, then what you have to do is very simply we have to just calculate the based on this formula we can just calculate the height of the object. So what we have to do is just we have to take a scale, we have to measure the top to the base of the object, and we have to measure the radial distance from the principal point. I hope you remember what is a principal point. So always remember, principal point is very important term while measurement of the aerial photograph. So if this is the aerial photograph, so you have a principal point here. Okay, so always the principal point is the center of the photo. Center of the photo. So how we make the principal point? So in all the aerial photograph, you have a fiducial marks at the center of the all the sides center of the photo, where you can just join this all 4, and finally you will get a center of the photo. Finally, you will get the principal. So if you know the principal point, then only we are able to measure the height of the object. So principal point is very important term. Nadir point, fiducial marks, these are all important terms. If you remember that all, then easily we can measure the height of the objects by sitting at one place. So we need not go to the main actual ground to find the height. By using the aerial photo itself, we are able to find the height of the object. So this is one method of finding the height of the object with the help of relief displacement. So there are other different methods by using 2 photographs or 3 photographs that we will be discussing in the other lecture. Now again you can see this one more picture here. So note relief displacement in a quick bird. So this imagery is a quick bird image. Quick bird is the satellite camera With narrow field of view, displacement is effectively the same throughout the field of view and depends on the tilt of the view angle. So here you can see the very clear picture here. So this is the displacement. So again, same formula what we have to apply: top, base. So you have to measure this distance, top and base, and the radial distance from PP. If the principal point is here, what is the distance? R. So this is D, this is R, and if you know the flying height of the plane, then we are able to measure the height of the object. Some more examples I have kept here. So this is a picture where you can see most of the places you can see the top of the buildings, top of the building. Few of the object it has a displacement. The reason behind it is shown here. That is because of the tall buildings, they have more displacement. So rest all will be having a short height. So here it is little taller than the other buildings. So that's why we can find the relative displacement here. There's one more point here. There's one more point here. Okay. So I hope you understood about this relief displacement. So basically, relief is about the different types of variations on the ground, that is up and downs. So that variations can be naturally, that the variations can be man-made also. So naturally, you will be finding about the hills, mountains, terrains, sea, plains, and all. So by man-made, what the structures are made, that is not equal heights. So most of the building will be having 5 floors, will be having 6 floors, some building will be having 10 floors, 20 floors. So more floors, whichever building will be having, it will be having more height. So more the height of the building, it will be having more relief displacement. So in a vertical photo, only the top of view we can see, but in a same vertical photo, slightly if the camera is tilted, then you can see the taller buildings side view. So based on the side view of the taller buildings, we are able to measure the height of the object with a single photograph. That is optic photograph. We cannot measure the height with a vertical photograph. We have to take a low optic photograph. Then only we are able to measure the height of the object. Right. So these are the references from where this content is taken. It's like MMG Reddy, Remote Sensing Engineers, DS Publications, New Delhi. So this is very good book where we can just refer with for this photogrammetry. And you have a fundamentals of remote sensing, and these are all web links from where we can just go through these links and find out the actual content for this topic. So that's all for today. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.